graphical example of limits that occur near asymptotes when you have asymptotic behavior, both horizontal asymptotes and vertical asymptotes. Excuse me. All right, so here's a graph that has one vertical asymptote and two horizontal. So vertical would be the up and down, that's this x equals 2 line, and then it has two horizontal. Y equals 2, that's this line, y equals 2, and this other dotted line down here, y equals -2. So vertical asymptotes are whenever you have like a break in the function where the endpoints in the break are shooting off to infinity, and horizontal asymptotes are what's happening at the tails of the graph, right, as x goes to infinity. So those are the ones we're looking at. So the first set of limits are as x gets bigger indefinitely or negative. So as x approaches negative infinity and as x approaches, it's okay that we're approaching infinities because we don't ever get there, and that's fine because the limit doesn't care if we get there. It's just happening near there. So as I get closer and closer and closer and closer to infinite, so I keep getting bigger and bigger and bigger, what's the function doing? So as x approaches positive infinity, what is the y values doing? Are they approaching a number? What's the function doing? That's what the limit behavior is looking at. So x is approaching positive infinity. That would be over here. As my x values go off bigger and bigger and bigger, right? My x values get bigger. What's my function doing? Well, my function is this green thing, right? The green piece is my function. And so as the x values, I plug in bigger and bigger and bigger x values, I'm up here on this green line, and the behavior of it is it's approaching that asymptote y equals 2. And so the y values, the function values, get closer and closer and closer to the horizontal asymptote y equals 2. And so they approach 2. The horizontal asymptote. Y equals 2, if you can read that. Apparently this corner is hard for my right-handed. Alright, the horizontal asymptote, so it's approaching 2. I still can't write asymptote. Alright, so it's approaching 2, the horizontal asymptote 2. So there's no left and right to infinities, there's only one-sided. So if you wanted to be technical about that, there'd be a plus there. It would only ever be there'd be minus there. It'd be only approaching it from the left. I'm getting bigger and bigger as I approach it on one side. You can only approach one side of an infinity. Right, now the other infinity. As x goes off to big negative numbers, what's the function doing as it's behaving that way? Well, now I'm on the other side. Alright, so I'm over here. My x values are going off to big negatives, shooting off to big negative infinity, big negative numbers. Well, what's the function doing? Well, again, the function's the green part, so what's the green part doing? So if I come down here, the green part of my function at the tail end of the graph is approaching this line y equals -2. And so the bigger I plug in, the bigger negative values I plug in, the closer and closer and closer my y values get to -2. It approaches the asymptote -2, y equals -2. And so, that limits 2, and this limits -2. As x approaches negative infinity, my function approaches -2. It approaches the horizontal line, y equals -2, horizontal asymptote, y equals -2. Alright, so those are horizontal asymptotes. Horizontal asymptote deals with how the function's behaving if it's going off to infinity or negative infinity. If it approaches a number, it's approaching an asymptote. Approaches 2, 0, -2. it's approaching an asymptote. If it's getting bigger or smaller indefinitely, it's not asymptotic behavior. It's just shooting off to infinity or shooting off to negative infinity. And the last two has to do with the vertical asymptote, 2, right? I'm looking at 2. X approaching 2 from the right and X approaching 2 from the left. So X approaches 2 on the right side of 2. What are the function values doing? And then we'll look on the left. X approaches 2 on the left. What is the function doing? All right, again, it's got asymptotic behavior there here in the graph. So I'm going back up here to the graph and I'll pick a different color. All right, so first the right side. So the right side would put me on this side of 2. This is on the right of 2. And so I'm going up here, and so if I look at this, the function, the green part of my graph, it's shooting up. And again, it never hits the asymptote. And so it's shooting up indefinitely. It grows. The closer to 2 I get, the bigger the function value. As I get closer and closer to 2, my function gets bigger and bigger and bigger and bigger. Goes to infinity. And so we actually do write it equal to infinity. All right. So it's going to infinity in that case. On the left side, well, I'm going to go back up here and look on the left side. So on the left side, that would put me on this side, right? The left of 2. Well, the part of my function to the left of 2 is this green part down here. And to the left of 2, it's approaching 2, getting closer and closer and closer to 2. As it gets closer and closer and closer to 2, the function's going down here to really big negative numbers. It's approaching negative numbers. So negative infinity. And so we'd say in this case, the general limit, I didn't ask for it, but the limit as x approaches 2 of f of x does not exist in that case, right? Because one side's approaching infinity and one side approaching negative infinity, right? So we'd say the general limit does not exist. All right, so that's a graphical example of infinite limits, and I'm going to do a second graphical example. I'm just going to go ahead and continue it on in this video because there's only 2 limits on the next graph. So this is a graph, again, it's similar to one we had before, and I'm interested in the behavior at the tails and at the asymptote. All right, so first off to negative infinity. As x is shooting off to negative infinity, so that would be over here. As x is shooting off to negative infinity. What's my function doing? Well, my function's that green part. Well, it's approaching, if you see that there, that's the x-axis. Well, that is an asymptote. The x-axis is the line y equals 0, the horizontal asymptote, y equals 0. And so that's what's happening here. My y values are approaching 0. My function, now on this tail, they don't actually get to 0. They do get to 0 here, but I'm not interested in there. I'm interested in it as I'm shooting off to infinity. And so the answer to this is 0. Right? As x gets bigger and bigger and bigger, my function's getting closer and closer and closer to 0. And so as x shoots off to negative infinity, my y values, my function values approach 0. So it means the function approaches the horizontal asymptote y equals 0 as x goes to negative, and only as x goes to negative infinity. Alright, now the next one. As x approaches negative 5. We actually did this one before in a previous case. If you look here, here's my negative 5, and it is asymptote behavior. There's an asymptote here at negative 5. On the right of negative 5 and the left of negative 5, it's shooting off to infinity. On both sides, my function, the closer I get to 5 on both sides, my function's approaching infinity. It's getting bigger, 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 and bigger and bigger. And so that was sort of a catch case. There are 2 acceptable answers in this case. You can write positive infinity, because technically it is approaching positive infinity to the left and the right. Another acceptable answer is does not exist, because technically the infinity is not a wall, right? I'm just getting bigger and bigger and bigger and bigger and bigger. Both of those for this class would be acceptable. Alright, so that's why we more like explain what's going on is what we'll be asking you in these types of cases. As x approaches -5 on both sides, the function, the y values, approach positive infinity. There is a vertical asymptote. At x equals -5. Then the last question. What's happening as x, so as x goes to positive infinity, what's the function doing? Well, that's on this tail, right? As I'm shooting off to positive infinity, well, my function itself is also shooting off to positive, right? My function's growing indefinitely, so there's no asymptote that it's approaching. And so, again, we just say it's growing indefinitely. It's approaching positive infinity. It grows indefinitely, if you can read that. Alright, we'll stop there. The last thing from 1112 is continuity, and so that's going to be the last set of notes for this first week. 1112 set of notes. Alright, so we'll stop there. We'll pick up continuity in the next video.